An electric arc flash is a dangerous release of energy created by an electrical fault that contains thermal energy, molten metal, pressure waves, acoustical energy, and debris. Until we began to capture arcs with super slow motion cameras, the molten metal component was less apparent, but is a significant ignition hazard. The thermal energy released in an arc is expressed in calories per centimeter squared. A typical arc flash can release energy from a few calories up to 20, and exposures between 20 and 40 calories are not uncommon. Everyday clothes made from cotton or polycotton fabrics can be readily ignited at these exposure levels, and once ignited, they will continue to burn long after the arc flash is over, dramatically increasing the extent and severity of burn injury. Several years ago, it became apparent that NFPA 70E was growing rapidly, would be the primary standard of the future, and that a large number of maintenance and electrical workers would be affected. Westex recognized in 2003 that existing arc flash work was focused on the utility environment, which is quite different from the typical industrial arc event. So, we made the commitment to invest in research with common industrial electrical gear to better understand, quantify, and document the industrial arc flash hazard faced by workers every day. As far as we're able to determine, the work in this test series is the first of its kind and scope in the world, and we're happy to be able to share it with you. This includes a new series of arc flash videos shot in super slow motion at 3,000 frames per second, which is 100 times slower than standard video. This technology allows an unprecedented look at industrial arc flash and an outstanding look at the projection of the molten metal. Westex worked with Mike Wright of 70E Solutions to custom build a one-of-a-kind sled with a common 480-volt bus at the bottom and 30, 100, and 200 amp disconnects installed above. We created the arc flashes by placing a tool or a wire across all three phases. Our goal was to create real-world arc flashes using common 480-volt electrical equipment to help companies better understand the magnitude of the arc flash hazard that exists in nearly every facility in the world. There are a number of critical differences between most utility arcs and most industrial arcs, and while some of these differences have been understood theoretically, little if any fieldwork had been done to demonstrate and characterize them. There are also key differences from arcs created in a Faraday cage in a lab and arcs created in real equipment. It was these differences that we hoped to better understand and document. The learnings illustrated by the events on this video clearly demonstrate that industrial arc flashes are extremely hazardous events, despite lower voltage versus utilities, and that there is no situation, regardless of hazard analysis data, where you can be assured that non-flame resistant clothing will not ignite, regardless whether the fabrics are blends or 100% cotton. Arcs were captured with no mannequins to fully capture the event, with mannequins wearing 100% cotton and polycotton, and with mannequins outfitted in Westex ultra-soft flame-resistant clothing, both new and after 100 industrial launderings. The stripes and numbers that you see on the wall represent feet from the arc gap to illustrate the hazardous zone. Safety professionals and engineers from many Fortune 500 companies, training centers, and leading unions were in attendance to experience the arc flashes in person. The testing clearly demonstrated that if you work on or near energized parts and equipment, flame-resistant protective apparel and other PPE can and does dramatically reduce injuries and save lives.